Welcome back to another episode of the 5G Guys. I'm Wayne Smith, joined by my co-host Dan McVaugh.
Hey Wayne, hey everyone, welcome back. Real quick reminder, if you haven't yet subscribed to our newsletter, go to our website, 5gguys.com, subscribe to that newsletter. You'll get a weekly email with some of the coolest tech stories of the week, and also you'll get notified when we have new releases of the podcast. So today we want to talk about cell service from satellites. You may or may not know about some of the advancements over the last few years in that space, how satellites are being used to augment cellular service on the Earth. So today we're going to talk about that, and we thought who better to have than today's guest, Tarun Gupta. He's the co-founder and chief product officer of Skylo Technologies. Skylo is a global network provider that provides connectivity for IoT, SMS, and soon to come voice services here on Earth. So prior to Skylo, Tarun worked for Google. He was the head of strategy and operations for Google Assistant, and he also helped work on the Google Fiber project to bring connectivity to thousands around the U.S. So Tarun, thanks for being on. Excited to have you.
Thanks for having me. I definitely appreciate the time, guys.
So start us off. Give us a quick intro about Skylo. Tell our audience who you guys are.
Absolutely. So we started in about 2017. We are an NTN, non-terrestrial network, which is a fancy set of words for satellite. We are a network service operator. We operate in 4 continents today. We connect existing devices to satellite. And so these devices are the same device you have for cellular. So it could be, an IoT device, it could be a smartphone, it could be a wearable. And because of what we've done, we've been able to connect devices the size of an Apple AirTag directly to satellite. And so what that means really is that your existing devices, or you, will always be in connectivity if you want it. So, there's always these macro holes in coverage when people talk about a national park, or these micro holes in coverage like the park near my house or in people's backyard to their driveway. And so you always want to make sure you have coverage at least from a narrowband perspective, and making sure that you're able to connect, whether it's checking in with your family that, hey, I'm late, or whether it's, an SOS as Apple has done, or whether it's anything like that. So, I think from our standpoint, we believe that connectivity shouldn't really be a choice. I mean, you should have it and you should choose not, if you don't want it or not, but you shouldn't have to be like, I have to live in a urban or suburban area to really have to have services today. We use the biggest difference with us, though, is we use a standards-based protocol. So the 3GPP a couple of years ago, that's the standards body that really helps to make all cell devices work kind of globally. They came up with what they had is called Release 17. So this is their latest release, or their release at that time. And they had said, hey, how do we connect existing cellular to satellite? And we are using that protocol. So it's a standards-based approach. So it's nothing custom. You don't have to have a different waveform, a different device, and then different antenna. It's, again, that sort of that common platform. So you could go down to your local DigiKey or your REI or a Costco or a Best Buy and buy these devices and connect those to satellite, and they'll work in cellular, work on Wi-Fi when you're at home, work on cellular when you're kind of outside and in cellular coverage, and work on satellite when you don't have either of those coverage opportunities.
Got it. And that's kind of a good segue. You mentioned Apple. So, before I learned about Skylo and met you, I was familiar with the landscape of some of the agreements that companies like Verizon and AT&T have made with AST Space Mobile. T-Mobile has an agreement with Starlink. As you said, Apple is working with Globalstar to do SOS from your phone if you have an iPhone 14 or later. Tell us what's the same and what's different between what Skylo is doing and what some of those agreements and that technology is doing.
Yeah, I mean, I think the first thing to recognize, at least from my perspective, is extremely excited that the worlds are colliding, right? Satellites have been around since the 60s and 70s and so, and, I remember like my parents making an international phone call over satellite, and it was expensive and, a lot of latency and a lot of echo, and just didn't really work. And out of the minute phone call, 38 seconds was saying hello to each other, right? And so it's really exciting for me to think about how your standard device now can connect to satellite when you're outside of cellular coverage, and how ubiquitous that technology has become. And, Apple has done a great job at educating the market that, hey, from your smartphone, you can have these types of these types of connectivity options. And I'm really excited the fact that just like when I helped to build the first cellular network in California, these are savings people's lives, and that's probably a very important way to look at it. And those first few bits that people send are the most important and the most valuable from just a life perspective. So when you look at this, there's sort of three main options that are coming out in the marketplace. One is the Apple way, which is a proprietary way, which is a proprietary waveform, proprietary set of satellites, and a proprietary device that you need today. So if you think about, what Apple has done, is they've connected an Apple iPhone, as you mentioned here, 14, 15, and likely 16, beyond to satellite, but you have to have an iPhone device. So it won't work on a Samsung. It won't work on a Google. It won't work on another Android device. It'll work on Apple. So for a person, that's great if that's what they want, but it won't work if they want to measure or monitor, let's say, the soil moisture in the middle of a farm, or measure where their kid is, or measure where the things are. So it's a proprietary ecosystem that's there. The second sort of vertical that's coming out, the second option that's coming out, is a non-standard space, sort of, again, this AST Space Mobile, this Link, the Starlink type services, which is basically a brute force tower in the sky mechanism where you're connecting existing cell phones to satellites. But in order for that to work, three things kind of need to happen. One is you need the local, so first of all, you need the companies to be able to put up satellites, build, operate, and maintain satellites, which, is no easy feat, whether that's technically or capital wise, or, just sort of that. And, if you look at what happens, there's a lot of challenges even to this day with launch and, issues with satellites as they get built and deployed or whatnot. So that's no small, and frankly, there's companies that do satellite launches for a living, let alone satellite plus operations plus support, right? So it's a very complex sort of business. And then the second thing that needs to happen is each country needs to have regulatory approval that says, hey, this spectrum that used to be used for terrestrial now is used for satellite. And so if you think about the 180x countries that are global, they got to think about, okay, well, this spectrum was terrestrial. How do we reallocate this? So that's a very time-consuming process to get through that regulatory change and hurdle. And some countries have already said no. By the way, they said, hey, some have said we're thinking about it. Some have said absolutely no, but the vast majority are still in this just we don't know phase and kind of what to do. And then the third thing that needs to happen is the carrier themselves need to give up spectrum. So, when you think about T-Mobile and Starlink, Starlink has clearly shown that they're able to launch and operate satellites. But I think the spectrum one, not just from a regulatory standpoint, is up for, it's still in flux, but also T-Mobile has to give up spectrum. So what does that mean if I'm a Verizon subscriber on a compatible device? It won't work, right? Because I'm not a T-Mobile sub. So is that really what you're trying to solve for? If the intent here is to provide a ubiquitous solution and really make sure that anyone and everywhere is safe, then you want to make sure that you're not sort of limiting that to your carrier. And that's what Apple has done. That Apple has made SOS as a function of the phone, not a function of the operator here, right? So I think, look, it's quite nascent. It's a brand new landscape. There's a lot of there's probably no single right answer, but from us, what we've done is we said, okay, let's think about this holistically. We are a standard space operator, so you don't need a specialized device. We are using existing satellite licensed spectrum. So this is spectrum that is used and authorized by the FCC and frankly, all 180x other countries globally that says this is satellite spectrum that is going from space to ground and ground to space. So it's a complete complement to the mobile operators. It's meant and designed and regulated for this service, and therefore it can be a blanket service. So let's assume a cell site is, like the disasters in Maui, they get damaged. You immediately have coverage. You don't have to re-farm or replant spectrum. Let's assume you have this situation where a cell site is down for maintenance. It's a blanket overlay. So the way I think about it is, this micro macro. This is like a super macro cell that kind of sits on top of everything here. So I think the exciting thing for me again is like it's not one tool in your toolkit. There's a lot of different tools that people are looking at, and look, there's pros and cons to each. It's really around how do people think about the value of what they want to give up, what they want to, how quickly they want to get to market, and what problem they're trying to solve.
Yeah, I mean, super interesting. You bring up a couple, I guess, technology terms, and we kind of like to make sure that we understand Internet of Things, IoT, and help explain what IoT means in this use case.
Yeah,
because as you talk about cellular, it's more than just Internet of Things.
no, absolutely. And I think it's interesting when we look at these devices. There's a huge people think about cellular. At least when I think about cellular, I think about your smartphone because that's what everybody has today. But there are many, many more use cases that are coming out to, for example, tracking a truck, or tracking a cow, or tracking a kid, or like I said, measuring sort of like we're on tsunami sensors in the middle of the ocean, as an example. Like, hey, what's the height of the water, or what's the temperature of the whatever, and it's a being, right? So, like, IoT is really it's really a way to bring low bits, high value services for remote devices to allow you to make good decisions. And again, like, we're talking to farmers to measure cows, and it's a big joke in the industry, but it's so funny because I talked to this farming consortium a couple of months ago, and they were like, okay, like, hey, we want to measure the cow, kind of where it's going. And I was like, well, why do you care? They're like, well, this is the standard. It's in my land, making sure it doesn't go into the neighbor's land or whatever it is. But the farmer was like, hey, this is interesting for me because not only am I able to see the health of the cow, like, are they sick? Are they moving? Are they eating? Are they doing whatever? But now from my iPad at home while watching TV, I can draw a digital fence. So I don't need to hire anybody anymore to go drive the hundreds or thousands of miles of fence I have to repair it every day. I've created a digital barrier from while watching television to be able to track where my animals are and make sure they're okay. So, IoT to me is like, it's all those interesting things that you can do with new and big data that are coming in to allow people, whether you're a consumer or enterprises, to make better business and life decisions.
Yeah, one little quick add-on. You mentioned early on about narrowband, and so what is narrowband compared to other types of technology out there?
Yeah, and narrowband. I mean, so when the 3GPP released these standards or ratified these standards a couple of years ago, they actually came out with the NB-NTN, the narrowband NTN, non-terrestrial network services, and the NR, the new radio NTN services. And what they recognized was there's just like any network today, there's like a low bandwidth and a high bandwidth services. We are focused on narrowband, basically low bandwidth services, which is low number of bits, high value of those bits. Because again, if you're tracking the location of a cow, that cow doesn't need to be watching Netflix, right? You don't need to be watching YouTube. You don't need. So for me, like, we wanted to make sure we wanted to understand the value of it here and the value of what people can get. And we wanted to make sure that narrowband was, again, it's probably the best way that I think about it is it's 1G. We're back at the 1G, 1.5G, 2G world, as opposed to the 4G, 5G world that we live in today.
Yeah, and I've talked about this when people have asked me about satellite-based services, and it's probably a question you've gotten a lot is, hey, is everything going to end up being satellite someday? I've been in zoning hearings where the zoning board says, hey, do you really need that cell site to be built because it's all going to be satellites someday? And my answer is always, no, these are all networks that work together. Like you said, they're all tools in the toolbox and they augment each other. And I think the best example that I try to give people is, even on a narrowband basis, there's certain services that are always going to be better served by a terrestrial network. Yeah. But when you can take those other services off the terrestrial network, it lets those terrestrial networks do what they do best and not have to worry about those other services. And so I've always been of the opinion that's where companies like Skylo and the like really are going to benefit everybody. And what better evidence of that than the fact that all of the terrestrial carrier networks are doing deals with satellite companies. It's not because they're going to get rid of their terrestrial network, right? They see the value in partitioning off certain network traffic items that don't need the bandwidth or don't need the the power, for example. I mean, the law of physics isn't going away, right? The satellites are still a lot further away than a terrestrial network will ever be, and we won't change those laws of physics.
Nah, look, completely agree, right? I mean, wireless has been around, or cellular has been around for probably 40 years or so, plus or minus, and really accelerated in the last 30 years, and then obviously 4G, 5G stuff in the last dozen or so. But to my house, I still have fiber. I still have a wired connection, right? So, I know a lot of the wireless companies are doing a lot of new and innovative things with fixed wireless and those types of things. But at least for me, it's always around to your point, what tool do you need for that situation I'm in? When my kids are home and they're on their Zoom calls or they're watching those HD shows or whatever they're watching, I need a wired connection where I'm getting that gigabit to the house or whatever that's there. And then when you're outside and your screen isn't, a 20-inch screen, it's a 4-inch, 6-inch screen. You want to make sure you have something for the resolution for that. And, you can't be tethered when you're out and about or whatever it ends up being. So I think for me, satellite will never replace cellular, just like cellular will never replace a wired connection and won't replace Wi-Fi in the house, right? So I think you'll end up having, to your point, where do you need to be? And look, and you see, Starlink making great hay with their terminal that's there, and I'm guessing Kuiper will do the same sort of thing. And for those RVs, when you want to go drive out and have that type of service and park and do cook out and have s'mores, you're going to put up your little Starlink terminal or your Kuiper terminal and have a little local Wi-Fi connection for that high speed, broadband type of connection. That it makes sense. But again, I'm not going to strap a 2-foot dish to the top of my kid or my skateboard or my bicycle to figure out where the heck it is. It's just not going to work.
And we talked at the very onset in the introduction about soon to come for Skylo voice services. Yeah. And I think a lot of people may not realize that voice is actually a relatively low bandwidth service, isn't it?
It's interesting. So absolutely. I think in the last couple of years, these companies, the large tech companies have done some amazing work in terms of voice vocoders and codecs and that are very, very high quality with very, very low bit rate. When we first did when I first helped build up the mobile network in California, we were doing a 7 kilobit vocoder and we were moving to 13 kilobit, and the MOS scores were the quality scores were quite high at that time. And now you're seeing fractions of those numbers with a high quality score. And so when we think about the use cases here on a smartphone, for example, if you think about the deck of cards of services, you have to have narrowband or some sort of data. You have to have SMS, and we think voice is the 50-second card in the deck, right? It sort of completes the deck where you have to have voice. You may not use it a lot, but you want to make sure you have it in the event of an emergency or that quick 5-second phone call. It's not meant for the conference call when you're on the beach. It's not meant for, hey, the Zoom call kind of when you're out in the middle of nowhere. I mean, if you're hiking in Yosemite, you're going to be hiking in Yosemite. You're not going to be on the phone. You're not watching Netflix, in my opinion. So I think, for us, voice is really important to round out the services. We're still working through the use case and kind of how people will use it. But I don't think I talk to my kids. It's rare they talk on the phone. It's all texting back and forth. So unclear what'll happen anyway.
Yeah, that's an interesting thing. So this technology, and I don't think a lot of people realize that it has been highly utilized for safety. Yeah. And like the spot trackers and the inReach from Garmin, this is the type of technology that empowers those devices, correct?
It is. However, I would say that the Garmin device and the inReach device, again, great devices, great organizations. These guys, it's back to that custom bespoke architecture. So it's okay. That, hey, I need a special satellite chip in the device. I need a specialized, waveform. I need a specialized battery pack. It's when I think about my cell phone, right? I mean, probably the least thing I use it for is a phone anymore. I use it for everything else. I use it as a calculator. I use it as a camera. I use it as to open my car door. Just all these things. And so what we realized was we want to make sure that we don't want to change user behavior. We don't want to bring in another device. You don't have to make sure that people are saying, hey, how do we have to go hiking now, or, an impromptu hike or wherever you are, and forget even being out, in a hike. Just imagine random roads where you're driving to somewhere and there's a hole. You don't want to have, oh, I didn't bring my tracker or whatever you need to be, right? So it's one of those things where you have this with you, and again, and you can choose whether you use it or not, but at least you have the capability to do so.
I have another question with regard to, I think, what might be a difference. A cell site has a radio. It might be on a tower, right? And that radio is making the connection to the device or the cell phone in this example. So in some cases, the satellite has to have that radio in space to make that connection to the cell phone on the Earth, right? In the case of Skylo, explain to us, is that the case for your application as well, or is there a difference?
It is different, and it's different because of how we chose to implement it. So if you think about a cell site today, the majority of the cell phone network is actually wired, right? It's the wire from the internet basically to the base of the tower. It's only from the tower to the phone that's a wireless connection. And so what happens is there's a cell phone that's wireless to the tower, and then today on the cell phone network, it's wired from the antenna to the radio that's usually sitting on the ground there. What we've done is we've taken that exact same model, except we've taken the antenna to base station connection, and we've made that wireless as well. So our base station is in the ground station of our satellite partners. So it's the exact same architecture where a radio or a base station is talking to a smartphone or an IoT device, but our base station, instead of being 2 miles away from the cell phone, is 36,000 kilometers times 2. We're 72,000 kilometers away. But it's the exact same connection if you were to draw it on a whiteboard, just longer lines. So what we've done is we've said, hey, we put it on the ground for a couple of reasons. It allows us to get to it a lot faster if in case of an issue. It allows us to upgrade it. It allows us to do some testing and whatnot, and allows us to do development. So, it's important for us to make sure that we think about at least this type of network as a network, frankly, as opposed to a single connection. And we want to make sure we have full flexibility, especially as the industry is nascent and thinking through kind of how to go and then really optimize going forward. And that having that base stations on the ground allowed us to do a couple of things. Like if you think about satellite launches, expensive, time-consuming, regulatory headaches and challenging, this allowed us to get to market today without having to wait for those satellites to get launched and without having to change any of the existing satellite infrastructure. So when you go to, again, any of our satellite partners, Viasat's a great example, and you say, hey, we want to offer direct-to-device, and we can do it tomorrow. It's a tremendous value proposition, not just for them, but also the consumer and our customers as well.
And then, okay, and so I think that's a huge difference because as a network operator in my past, I'm just sitting here with, I'd be up all night thinking about how am I going to maintain and upgrade this network in the future. It's going to cost me a fortune and a ton of time to launch new radios, to deploy a new spectrum band, or to go from 4G to 5G or 5G to 6G. So that was one point I really wanted to make sure we pointed out for our listeners. The other point that I think is interesting is that Skylo is basically like a roaming partner. So almost any carrier can agree to do business with Skylo, and their customers can now leverage the Skylo network to have this expansive coverage around the globe, versus in the situation of, say, a Starlink and a T-Mobile or an AST and a Verizon. That's a very one-to-one exclusive relationship. And so my service is going to be limited to whatever that non-terrestrial provider can give me. Is that correct?
Yeah, I think, Dan, let me just go back to one other comment you made around having our base stations on the ground. When you think about a LEO constellation or a LEO low Earth orbit constellation, and you think about the base stations being on the satellite, if there's, these LEO constellations, I've talked about hundreds, if not thousands of satellites that need to be deployed. But when you think about a LEO constellation, all the radios have to be deployed in order to cover a country, because it's either upgrade all, all tens of thousands or zero of them. You don't really have it because all the birds are sort of covering the same geographical area over time. For us, if we wanted to change something over US, we have to just change those base stations out. We don't have to do something over another part of the world. That's an example. So it's much more modular and much more simple in terms of maintenance operations type. In terms of your question here regarding, the ASTs and those things, it's important, again, to your point, we spent a lot of time thinking about how do you work with the operators? And to work with the operators, it can't be a change in behavior for them or the consumer. So we said, okay, the best way to interface with them is how does AT&T, as an example, interface with Verizon or interface with Vodafone, let's say in Europe? It's a roaming relationship. They have standard connections. There's companies designed and built around these things. We use those exact same protocols, those exact same infrastructure. So I was on a call about a year ago with a major mobile operator, and he set up an hour call with us around interfaces and how do we connect and how do we hand off traffic and how do you authenticate the service and all the right words that were there. And we get on the call, and I was like, we're roaming interface. And he kind of looked at it and he's like, that's it? And I was like, that's it. And he's like, great, call's over. I mean, so it really I think when you embrace the ecosystem and embrace, like, one of my colleagues says it best, that we're really standing on the shoulders of giants here, that the industry's built these ecosystems. They've built these systems and plans and procedures in place. We don't need to reinvent those, because this is not like, just because I have a different medium doesn't mean it's a different network, right? So it's just a roaming interface, and that allows then, but what it does as a operator, it allows, let's say, an AT&T or Verizon or a team or whatever it is, whoever's using my network, to keep their same SIM. So they maintain the relationship with their subscriber. They don't have to work. Like, I'm basically international roaming, just kind of different, right? So I'm kind of international roaming for them. And once that's understood, which is a very simple conversation, everything goes quite smoothly after that.
Yeah. Yeah, to your point, I think roaming is a part of cellular technology that's been there from the beginning, right? And we all go back a long ways. We've been in this industry, all three of us, for a while. 1G analog service was absolutely dependent on roaming. There was no such thing as nationwide carriers, right? We were building very localized networks and connecting them all together through that exact same roaming technology you're referring to. So I love to see that old tech, quote unquote, is still foundational and a big part of what we do today.
I mean, like I said, that's really what drove us. We spent, like I said, a lot of time thinking about how do we take advantage of what was already done and, frankly, optimized over decades. So it's not a brand new set of challenges or a brand new set of problems we're trying to solve. It's very, very quick, very, very simple. And I think we're down to, when we do our roaming integrations with our partners now, we can get these done in less than a month.
Oh, amazing. Hey, one question that comes up. So the customers of your Skylo are the carriers, per se. So with the emergence of private networks for enterprise, how do they take advantage of your technology to have a more international, flavor for them that costs them and works on their own private network?
I mean, if you look at what happens today, if you think about a private network, and the FCC has done a great job releasing new spectrum, whether it's CBRS or these things, and private networks make a lot of sense. And I think, again, it's another tool in the toolkit. If you're a let's say a large oil company or large energy company, and you have you have people distributed and assets distributed globally, you want to make so private networks work great on a campus, let's say. But how does it work for a global sort of tracking and tracing and making sure things are there and making sure the wellheads are okay and things? So I think this is another complement where you say, hey, look, guys, to the extent you don't want to, I mean, even if private network, you have to build your own cell site. It's your own radio. It's your own RAN. It's your own sort of core. It's your own sort of these things. And so it's really just keeping it to you. So I think, again, the argument of going into any enterprise and saying, hey, from your existing device, if it's on cellular, it'll latch onto cellular. If it's on private, it'll latch to private. And if you're not, you have satellite as kind of a safety net. You have this as an option. Choose to use what you want. I mean, it's a no-brainer to me, because I think, again, we're finding so many use cases and so many situations where people have in their head that satellite is sort of, expensive and custom. We're moving it out of that quadrant where it's affordable and just generic.
So as we kind of wrap up, I love to ask our guests for predictions. Would you be willing to play along and make some wild predictions about, what the landscape's going to look like for the combination of terrestrial and non-terrestrial networks?
I mean, I think that's a great question. I think from my perspective, it's not really a prediction because the industry's done it already. Like I've been lucky enough to be part of the industry from 1G all the way to this 5G and potentially 5.5 and 6G now. So I think on the satellite side, we're at 1G of that world. And so like it's very obvious to me that this will start at 1G, there'll be adoption, there'll be some use cases, and then this will go to 2G, it'll go to 3G, 4G, and 5G. So it'll take maybe not decades as it took in the cellular side. It'll probably take a little bit less time, but it'll take time for the industry to understand, well, hey, look, this is more than an SOS service. This is an SMS service. This is a voice service. This is now a mid-band, data service or whatever it is. I don't think there is like when I go with my family and we hike that, crazy mist trail at Yosemite, we're not on our phones, watching Netflix. We're out to be out. So I think from my perspective, like you probably won't get HD TV or whatever it is on your phone, but I think it'll probably stop at around email. That's my sort of view. And I think when I say that's probably the next decade or so is my guess, but you'll have to see these just like, the cellular world spent billions of dollars and years around how do you, build new cell sites and get them zoned and permitted. I mean, the same thing kind of needs to happen on the satellite side where these GEOs will have to move to MEOs as well as LEOs. So like I said, the industry's done this from 1G to 6G, and they've done this from macro cells down to, from macro to micro to pico to femto. This is no different. So I don't really see that as a tremendous leap of faith here, frankly, from my perspective. I just think it'll end up being how do you end up making sure there's a business case here that is aligned with what people want to pay. So you're not, building ahead of the curve.
Right. Yeah. Well, this is awesome stuff. Thank you so much for taking time from your schedule. Wayne and I love doing the podcast because we get to learn so much every day and help our listeners learn along the way. So tell our listeners how they can connect with both you and Skylo.
So Skylo, our website is skylo.tech. If you want the service, work through your local mobile operator, and they're sort of the customer here, I guess, and that way you're working with them in terms of how you're getting the service and packaging the service. But feel free to reach out to me directly, Tarun at Skylo.tech. Happy to get emails, happy to answer them, happy to answer any specific questions because. Look, I think to your point, Dan and Wayne, there's a lot of like misinformation and a lot of misconception in the industry, and I think at least from my perspective, happy to help try to clean things up and clear things up and tell you what we're doing, and happy to also answer what some of the other some of the other operators are doing because it's brand new and it's confusing and it's hard to kind of navigate.
Yeah, thank you.
Thank you for having me on. I appreciate it. Thank you.
Yeah, and listeners, we'll put links to connect with Skylo and Tarun in the show notes, so check that out. So until next time, thanks for being on.
Thanks for listening to the 5G Guy. For more resources and to connect with Dan and Wayne, check out their website at 5gguys.com. If you enjoyed this episode, be sure to hit that follow button and share this episode with your friends and family.